Welcome. Today we are going to learn electrical power demand requirement for the office area. This is a electrical layout for the load calculation and it has a very small office area. For this area, we are going to learn how to calculate the power requirement for this office area. Now in this drawing, there are multiple square type LED is placing over here. Then LED downlight is also there, as well as 6 ampere socket is also here. Like this is a 6 ampere socket to require each and every computer, as well as 6 by 16 ampere socket is also there. 6 by 16 ampere sockets required for the multiple equipments like printer, Xerox and etc. So here we will start the electrical load calculation required for the office area. For that we required Excel sheet. So this is electrical load calculation sheet in front of us. This is the first column is the tag number. Each equipment has the tag number. We can give the tag number for multiple equipments, electrical equipments like lighting is there. Then Xerox machine is also there. Then printer is also there. So different equipments is available in the office and we need to give a tag number for each and every equipment so that we can identify that equipment when we are placing that, when we are providing the electrical layout. Then next column is the item description. Item description is the electrical equipment description. Means is it lighting or it is any other equipment like printer, Xerox machine, or tea vending machine, anything. So there are the different applications and the different equipments available in an office. So we need to calculate the electrical layout, electrical calculation for each and every items. Then phase. Phase is there. Electrical layout or the electrical design philosophy says that it has the two phase, single phase and three phase. Some equipments requires a single phase power, whereas some equipments require three-phase power. For example, the equipments like lightings, Xerox machine, printers, tea vending machines, refrigerators and other equipments available in the office requires a single phase. Whereas when there is an entire building load calculation, there are some three-phase equipment is also there. That electronic equipments such as water pumps, lifts, these are the equipments, these are the electrical equipments required the three-phase power because the motor involved in that particular equipment. So we required a three-phase power. So we will mention what kind of power we are providing, whether it is single phase or three phase. So the column for the phase is also important in an electrical load calculation sheet. Next is the quantity. For example, here I can say the multiple square type LED is there. So if I put a single square type LED lighting watt, so I will calculate that watt by the quantity and throughout the total watts will be calculated in that particular drawing. Same LED downlight is also there. This is the LED downlight. So what is the typical watt required for LED downlight? I will mention into the item description and then multiply it by quantity. So automatically the input power in a kilowatt will, or the brake load will automatically comes. So that's why the quantity column is important and input power in a kilowatt is also important. Next column is the voltage. Voltage required just to mention the voltage. For example, if it is single phase, so I will provide 230 standard voltage over there. If it is three phase, so I will provide 415 volt over there. So we need to just mention this. There is no calculation behind this voltage with electrical load, but we need to mention the voltage itself. Frequency. We can mention the frequency also. My dear friends, in some countries 60 Hz is the standard phase we are taking, whereas in some countries 50 standard Hertz we are taking. So we can take anything as per the country required. Next is the break load. Break load is always the multiplication of input power load and the quantity. For example, I will mention the formula like this. Break load is equal to input power multiply quantity. So the break load will automatically come. Now for that, what is input power kilowatt? So input power kilowatt is totally depend upon the kilowatt of a certain equipment. Each and every equipment has the power into the watt, but we need to mention here as a kilowatt. So kilowatt quantity, kilowatt multiply quantity is equal to the total break load. Break load is the actual load required for that particular equipment. Means the break load is the actual load, but the next column, which is called connected load. Connected load is always 20% more than the break load. Means sometime when the voltage fluctuation is there and we need to keep a certain kilowatt or the certain watts extra, so that we will take tougher figure like 20%. So the connected load is the 20% more than the break load. Multiply this by 1.2, that is 20% more. Next is the power factor. Power factor for each and every equipment is the different, or maybe somehow the nearby. For example, I will take over here the power factor 0.8. It is the standard power factors we're using in an electrical load calculation. Now the load factor. Next column is the load factor. So the load factor is nothing but the division of break load and connecting load. So it will be is equal to this break load divided by connected load. So there is something, the load factor will automatically come. Okay, now it shows a wrong figure, but definitely when I put the input into the input power kilowatt, so automatically load factor will come. Next is the diversity factor. Diversity factor is totally depend upon equipment to equipment, and it can be given by the vendor. Vendor means who manufacturing that item. The item description, for example, the light is there, square LED light is there. So square LED light standard diversity factor can be calculated or can be given by the vendor. It may be 0.8. And next is operating load. What is operating load? Operating load is equal to break load multiply connected load multiply load factor multiply diversity factor. So it will come the operating load. Operating load in kilovolt ampere. Operating load in kilovolt ampere will be like this, is equal to operating load in kilowatt divided by power factor. So automatically operating load will become. So my friends, let us take an example by giving all the formulas. By putting all the formulas into the first row, I will show you the one example. For example, this is square type LED light. So this square type LED light has mentioned everywhere in a workstation, passage, meeting room 2. So everywhere there is the electrical lighting over there. Square type LED lights. So the standard square type LED light wattage is different by its manufacturer. Some manufacturers manufacture 10 watts, somewhere we are choosing 20 watts, some we're choosing 30 watts. So multiple watts are available with it.